This conference will now be recorded.
Okay, so switch case is an alternative for if-else loop. Okay, so there are two usage of using a switch case as opposed to if-else. Now, what is the input that if-else requires?
Boolean.
Boolean. Okay, all you can have here is just a Boolean value, some expression that resolves to a Boolean. Okay, now what switch case allows you to do is it can allow you to compare primitive data types, anything, int, byte, short, okay, char, and also string. Okay, it allows you to compare multiple options rather than just one Boolean. That is one thing. Okay. The other advantage of using switch case is more like an indexed version of if-else. Okay. So what I mean by that is when you're reading through a book, okay, and you want to go to a chapter called control flows, there are two ways you can do that. How is it?
Through if or like in a regular life?
In a regular.
You just directly go to that, just
Right.
wherever you are, just directly go to that page.
Mm-hmm.
And then second is you go back to the wherever the page where it tells you which chapters on which page.
That's index page.
Yes, that's it.
Okay.
Index page.
So
Yes.
one option you have is you don't have an index page. In that case, you start from page number 1 and you keep looking at every page after a page until you see control flows, right? So that's like a painful process. You start from page number 1, then compare page 2, compare page 3, all the way till you find what you're looking for. That is one. That's how if-else works. Okay, that's how if-else works. Switch case works more like an index. You see what you want to look for in the index, and it tells you that control flow is on page number 100. So you directly scroll to page number 100, and there you are. Okay. So performance-wise, switch case is faster than if-else. Okay. In switch case, if you have a variable like this, okay, so you have to compare like this: a equals 1, then do something. If a equals 2, do something else. You keep doing that until you find a suitable match. Okay, you compare the first condition, then the second, then the third. You keep doing that until you find a suitable match, and that's when you execute this. Okay, so that's like comparing the reading a book. Okay, going page after page until you find what you're looking for. In case of switch case, it is much more faster. Okay, because they are internally indexed. You directly jump to the page you're looking for. Okay, so switch case works like this. It takes a parameter, a primitive data type or string. Okay, you can have primitive or string, and you write like this: case 1, do something. Case 2, do something else. You do that all the way till whatever you're looking for. Okay, and just like if-else if has a default block, right? The else, which is a default block. Here also you have something called default. Okay, it literally is called default. So if none of the case matches, you go to the default. Okay, so this is just a substitute of what you can do, how you can write the same code that you have with if-else and switch case. It's just an alternative. Okay, if you notice, we don't have to do comparison or anything here. A equals 1, A equals 2, we don't have to do anything. Just pass the variable that you're tracking and write the number you are looking for. You're looking for integer 1, integer 2, 20, just do that. Okay, this is the same version that you have, the if else version that you have written in a switch case. All right, so it's like a switch case here. Okay, so this is a comparison. They both do the same thing. If a is equal to 1, you do this. If the case matches the value 1, it does that. It's the same thing. It's an alternative for if else with two benefits. One, it doesn't rely on only booleans. Okay, it can accept any primitive variable. You can pass integer, you can pass character, byte, or even string. Okay, you can pass any primitive data type or string or enums. Okay, so you have multiple options that you can pass here, rather than if else, which takes just boolean, expression that resolves boolean or any boolean variable. Okay, the other thing is this one is faster as compared to if else. Okay, if you want to reach this condition, you have to go through one by one. You have to compare this, compare this, compare this, then reach here. In this case, it's more like a jump. Okay, like an index. So this is relatively faster as compared to if else. Okay, now the syntax goes like this: switch, in the parenthesis you pass the variable, whatever variable you're looking for, whatever variable you're comparing. Okay, you're comparing the a variable for values 1, 2, 20, and so on. Okay, that's the syntax for switch. Here you write what you're looking for. I'm looking for value 1, value 2, value 20, and finally there is something called default. Okay, so this is the case if none of the values match, like if the a value is 25. Okay, if the a value is 25, you will not match any of the cases 1 to 20. In that case, it jumps to the default case. Okay, just like your else condition. Okay, now one last thing you need to remember is every case should end with a break. Okay, traditionally how switch works is it will jump to a, as the name goes, right, it switches. You're switching from one case to another, you're like jumping. Okay, so as soon as if this matches, okay, as soon as this case matches, it will do whatever instructions you are given here, sys out or whatever code you have written, it will execute this, but it don't stop there, it will continue with the rest of the lines. Okay, so this is mandatory. Every case should end with a break. Every case should end with a break. If you do not do that, it will continue executing every cases. It will continue with every cases. So you have to explicitly write break after every case. Okay, you have to explicitly write break after every case. If you do not, if this case matches, it will continue executing this line and so on until you reach the end of the switch case. Okay, so write break explicitly. Now one thing to remember is even though we are writing break, this is not a loop. This is just an alternative for if else. Is if else a loop control flow? Which are the control flows that allows you looping?
For while loop.
Do while.
For.
And for. Okay, loops are when you do the when you repeat the same thing over and over. Those are only done in for, while, and do while. If else, if they are not loops. And switch case is not a loop either. Okay, switch case is not a loop either. Okay, switch case is just like if else. It is a one pass, one execution only. Okay, it will go over this one time. Okay, break is needed so that you can stop executing once you are done with your case. As soon as you're done with your case, think about this like a limit, like a boundary. Okay, this break line is written to indicate that this is where the case finishes, this is where the case completes, and we have to stop right here. Okay, we have to stop right here to indicate that we write break. If you do not, it continues executing every line. Okay, let's look at this. All right, so switch, pass the primitive variable or string. You don't have to do Boolean comparison or anything. Okay, you don't have to do equals comparison anywhere. Okay, you can just write the variable name and keep going on there. Okay, it matched 2. Okay, if you do not write break after every case, it will continue going through every statement after it matches the case. Okay, in this scenario, a value is 2, so it will match case number 2. So as soon as it is done printing this, it will continue with whatever is remaining until the end of switch case. Okay, so make sure every case ends with a break statement. Okay, performance wise it is faster. Okay, and it supports multiple data type as opposed to if else, and it requires less amount of code. Okay, you don't have to write a lengthy process of a equals 1, a equals 2. You don't have to write that lengthy process. Okay, you can just write the variable and say which case you want to match. This also applies for string. Okay, so if you have string John, right, so you can say if it matches John, what do we do? If it matches Jane, what do we do? If it matches Mike, what do we do? Okay, it matched John. So it's easy to write as opposed to writing it in a if else. Okay, you don't have to write equals John, a equals John, do this, a equals Jane, do that. You don't have to write that. Okay, less amount of code, it is faster, and it supports multiple data type. Okay, not just Boolean. Okay, so those are the benefits of having a switch case. All right. So before we move on to constructors, any questions on the control flows? If else, if else, for loop, while loop, do while, switch case.
I have a question. If you just go a little shortly, break and continue.
Oh, you want to continue here?
No, I just want you to go through just a little quick break and continue. Yes.
Oh, okay, sure. All right, so which loop you want to try this in?
Do while.
Do while. right, so this is the code. Now this is your loop block. Okay, it starts from the curly bracket where the do keyword is written. Okay, it goes all the way till here. Okay, now when we say loop, what we are looking forward to is the block, the lines of code that has to be executed over and over and over again. Okay, so the highlighted lines of code, they are supposed to be executed multiple times. Okay, in a loop, this has to be executed multiple times. Okay, so the difference between continue and break. Okay, now we know that continue, okay, to write a proper code, I can write continue here. Okay, now this is one loop. You do that multiple times. Okay, you have the entire loop condition. Okay, in case of continue, what it means is you're supposed to skip everything and go back to the top, go back to the beginning. Okay, going back to the beginning doesn't mean you exit the loop. Okay, so continue means skip current loop and go back to the next loop. Okay, so see the difference here. Break exits loop, the entire loop altogether. So if you have a statement here, okay, if ever you encounter continue, it doesn't mean you will print this out. Okay, if you encounter continue, it doesn't mean this is where you come. Okay, it will go back to the beginning here. In case of break, there is no going back to the next loop. You directly come outside the loop. That's the only difference. Exit current loop versus exit the entire loop. Okay, it's like skipping one day of your college versus skipping your entire master's degree. Okay, that's the separation. Continue means you just skip for the one day, but don't you continue going to your regular sessions, your classes the next day? Okay, break on the other hand is you quit. Okay, you drop out of college altogether. There is no more college, nothing. Okay, that's the only difference.
Okay, gotcha.
Okay, so with that in mind, what will this program print? You start from here.
Just 4?
I is equal to 2. Is this true?
No.
No. It will print 1, print 2, print 3. Okay.
But you said it's gonna go back if continue means stop, right? Exit the loop. Why it's going on line number 6 then? If it's false.
Did this condition satisfy?
Oh, then no. Okay.
This is inside the continue, inside the if block. Only if you satisfy this condition, then
it's gonna stop. Okay.
Okay. All right. So since this did not satisfy, you move on with the next line. Yes, you are right. If it satisfies, continue means you skip all the lines, do condition check, and go to the back, go to the top of the loop again. Okay. Continue means skip all the remaining lines in that particular loop, check condition. If condition satisfies, go to the top. Okay. So it will print 1, 2, 3, and here i's value will become 2. Okay, we started with I equals 1, 2 I plus plus. Here the I value became 2. So So is I equals to 4?
No.
No. So you don't enter this either. You're not breaking either. This condition did not satisfy. Okay. So you don't break. Instead, you go towards the end and you do the condition check. So I value, is it less than 5?
Yes.
Yes.
So if this condition satisfies, you go back to the top. Okay. What will happen here?
It's 2 equals 2 now.
Yes.
2 equals to 2.
It satisfies.
Mm-hmm.
So what does continue mean?
Stop. There. Exit the loop.
Check the condition again. I
True.
value 2.
True.
Go back. Condition true. Continue. You are in an infinite loop here.
Oh yeah.
Okay, because the increment happened
First time.
after you skipped those lines. So since you hit continue here, you never got a chance to encounter line number 12 where the actual increment was happening.
Oh, okay.
Okay, and that's why it never allows you to go beyond the number 2, I equals 2, and you're stuck there. Okay, this would have ended safely if you are writing the increment here.
It's gonna change it.
This would have been safer. If you write the increment after the continue statement, you usually run into those problems. Okay, because continue means skip everything. So when you skip everything, you also skip the increment. And that's what made you in an infinite loop. So make sure you are careful on that part. Okay. All right. So any other questions?
No, that's it. Thank you.
All right. So can we move on with constructors?
Yes.
Okay. So let's take this example. Okay, we have a bank account initialized with $100, and we have customer name John. Okay, so we have these two global variables, and yeah, you have usual withdraw, deposit, all that code. Okay, so let's say this is your code. Now, these are already initialized with the default values, right? 100 and John. Okay. Now, let's say the bank has 10 customers. Okay. So we have to create an individual object for each of them, so we can manage them individually, right? So we have customer 1. I create a object for this customer. Okay, and I do that for like 5 different customers. Okay, so I created 5 objects for 5 different customers, our bank customers. Now, what's the problem you see here? Problem with this setup?
Yes.
Okay. What are they?
You're creating 5 objects, so that look like it's problem there.
It gonna all the customers' name and the money gonna be same all the time.
Yes.
That's the problem over there.
Okay, the problem is every single customer's name is John. Every single customer's balance is 100. Is that how people open their bank accounts? Do everyone have $100 when they open an account? Do everyone has the name John?
No.
Okay, that's where constructor comes into picture. Okay, constructor allows you to create object with custom values, initialization. Okay, this initialization, when you hard code, okay, this is hardwired into your program. Every customer who ever gets an object, they all will have this default value, which is the problem. Okay, if you want to make sure every time you create an object, you create with different name, different account number, different balance, then you need to rely on constructor. As the name goes, constructor. Constructor is like construction, right? Constructor comes into picture whenever you're creating an object or constructing an object. Okay, constructors step in whenever you are creating objects. Have you ever wondered, how do we call withdraw method? Okay, you have sys out. You have declaration. Then you have customer1.withdraw. Okay, so like we did the exercise, tell me the line numbers where we are calling methods.
Number 12. Number 12, yeah.
12.
And why do you say number 12?
And 10 both.
Okay, so you're seeing here, you're seeing the code here, and that's why you realize that's a method. But if you didn't know this class, how do you guess if it is a method or not?
We can.
Because of parenthesis.
Yes, any line that shows you a parenthesis, that's a method call. Okay, no matter what you pass a parameter, you don't pass parameter, any line that has parenthesis, that's an indication that you're calling a method, because methods have parentheses, don't they?
Yes.
Right? When you declare a method declaration has parentheses. So to understand, okay, just because I kept the bank account class side by side, you did realize that I'm calling a method on line number 12. Okay, the reason you said this is the line where I'm calling method is because you can see right here. But that's not how you need to figure out. Okay, when you're working on a project, it will have hundreds of classes. Are you going to keep 100 classes side by side to know if this line is a method call or not? Is that even possible to keep 100 classes in one window?
No.
No.
No. So what's the easiest way to find out which lines are methods?
Parenthesis. And
Parenthesis.
colon.
Look at the parenthesis. So any other lines you feel we are doing a method call?
5, 6, 7, 8, 9, 10, and the 12.
Very good, close enough. So that's my next point. These are not method calls. These are actually constructor calls. These are constructor calls. Line number 10 is a method call. Yes, there is a parenthesis. Line number 12 is a method call. There is a parenthesis. Okay, this is not a method call. In fact, it is a constructor call. So now you know that constructor and methods have a lot of resemblance, isn't it? They have a lot of resemblance. Okay, so let's see how we write a constructor. Okay, so this is the problem. We have 5 objects, created for 5 customers, and every customer has the same balance, same name, and same account number, which is not realistic. Okay, So let's see how constructor will help you out. The first rule for constructor is the name is similar to the class. The name is similar to class. Now do you understand what this line means?
Yes.
Isn't it exactly similar to the constructor? Right? Bank account parenthesis, bank account parenthesis, withdraw parenthesis, withdraw parenthesis. Okay, if this is a method call, what is this? If this is a method call, this is
Constructor call.
Constructor.
constructor call. Okay, if this is a method call, this is a constructor call. Okay, so the way you need to identify which are methods, which are constructor is if any line has a new operator, then this is not a method, it is a constructor.
Constructor.
Okay. If any line doesn't have new, then this is not a constructor, but it is
Method call.
a method call. That's how you need to figure out. Okay, constructors only step in when you are creating object. And how do we create object? With the new operator. Okay, using the new operator we create objects. Constructors are only called when you're creating objects. Okay, the syntax is exactly similar, like a method. What other differences do you notice between a constructor and a method? Pretty much almost everything looks same. First difference is the names are similar. Okay, the names are similar. What else?
We didn't have a return type.
Yes, it doesn't have a return type. Constructors do not have a return type. Okay, that's the second difference. Okay, the name should be always same and there shouldn't be any return type. Okay, because the job of having a constructor creating object is, what do we return from the right hand side?
Goes to the left hand side.
Yeah, but what do we give to the left hand side? What is assigned from right hand side to left hand side?
Memory block.
Yes, the reference address. Okay, the memory reference address wherever this object is created, right? Now think about it. If I make constructor return type as Boolean, when you create an object, you're supposed to return a reference address, memory reference address, right? But if Java allowed you to return something from a constructor, aren't you overriding this? And instead of returning a reference address, you're returning a Boolean. That beats the whole point of having a reference. Okay, so that for that reason they do not allow you to have a return type at all. Okay, because constructors are not supposed to return anything. When they create the object, all they return back on the left hand side is the reference address in the memory. That's what it is supposed to return. Okay, for that reason it doesn't allow you to have any return type at all. Okay, now just like in methods, you can have 0 or more parameters, right? You can have 0 or n number of parameters. Constructor also can have 0 parameters or n number of parameters. Okay, now this is what you do. Now do you see all these failing? Now one question, why would this one fail? Okay, you already know why this fails, right? Why is it?
It needs a
It's
parameter.
outside.
It needs an input, integer, isn't it? So am I passing an integer from here for this method call?
No.
No. Apply the same rule to constructor. What does constructor requires?
Nothing.
Here, this is the constructor. What does constructor input requires?
One string and
Parameters.
integer.
String and integer.
Okay. If a method requires integer, in the method call, you're supposed to pass integer, correct?
Yes.
If a constructor requires string, integer, integer, in the constructor call, what are you supposed to pass?
String integer.
String integer.
Integer and integer. Okay. John, money 100, account number 1. Error gone. Just like how the methods are dealt with. Okay. When you do a method call, what you need to pay attention on? If it requires integer, you have to pass an integer. That's what you pay attention on. Put the same care and thought in the constructor call as well. If this is the rule for method call, you have to apply the same rule for constructor call. It requires string and an integer and another integer. So that's why no more errors. Jane 202. Now, this is what happens, right? When you pass John 101, which variable does it go to?
Customer 1.
John 101 is passed to
It will go
constructor
to NMA.
N, M, and A. You're passing it's like a method call. When you pass 10, who gets the value 10?
Deposit.
A.
A in the deposit, isn't it?
Yeah.
In the bank account constructor, when you pass John 101, who gets these values?
The
Bank.
The constructor N, M, and A, isn't it? So this is what happens now. In case of John, okay, so let's keep default values to everyone so we don't mix it up. Okay, no one has any default values. Everyone will be getting a custom value when they create a bank account. Okay, so when I pass John, John goes all the way to the constructor variable N. 100 goes all the way to the constructor variable M. And the number 1 goes all the way to the variable A in the constructor. So on the right hand side, what do we have? N. Left hand side, we have the global variable, the name. Right hand side, the input. Left hand side, global. Right hand side, the input or parameter. Left hand side, account number, the global variable. So here, constructor is typically used for initialization. Okay, what do we call this variables as? Does anyone recall the 4 type of variables?
Global.
The global.
Global and local is just a general name. What is the specific name?
Class variable.
What is this called?
Instance.
Parameters.
These are parameters.
Parameters.
What is this called?
Local variable.
Local variable. Those are the 2 types. Outside you have another 2 types. What are they?
Instance
Instance.
variable.
Instance and class variables.
Instance and class variables. Okay, so this is an instance variable. For class variable we write static. Okay, static meaning class variable. If you don't write static, it is a instance variable. Okay, so what I would encourage you guys to call these going forward is with the specific name. No more calling them global variables. Is that clear?
Okay. Yes.
Because they have entirely different meaning. Global and local is a scope, visibility. The actual names are instance variable or class variable. Anything you declare outside as a global level, outside the method, they have a specific name. If you find anything called static in the beginning, they are class variables. If there is nothing, no static written, they are instance variables. Okay, remember that. So the main job of constructor is to initialize instance variables. Okay, what is initialize means?
Assign the value for the first time.
Assign the value for the first time. So here, did we initialize these variables?
No.
No, we just declared. So where
Declared.
are we assigning values to these variables?
Constructor.
Constructor method. Inside the.
In the constructor, we are assigning values. So this is the first time we are assigning values to instance variable. So the main purpose of constructor is to initialize instance variable. That's the main job of constructors. That's the main job. Constructor's main job is to initialize instance variable. Okay, this would be wrong. If you do like this without a constructor, the problem with this approach is every single customer gets the same balance, the same name, and the same account number because they are initialized with the same value over and over, isn't it? They will have the same value every time you create an object. So this is a hard-coded initialization. It's a hard-coded initialization, meaning everyone will get the same money, same name, and same account number. But with the help of constructors, we don't do initialization here anymore. We do that in the constructor. And who gives input to these instance variables?
Bank account.
Whoever creates the object. Whoever is creating the object, they will provide you a custom input. And this applies to everyone. Okay, you go, you're trying to buy a new car. Does every single car has the same color, same make, same model, same VIN number?
No. No.
So when you create a 100,000 car object, don't they have to be created in unique custom way? Each with their own VIN number, each with their own brand, make and model. Take Facebook account. If you create a Facebook object, Facebook account object, does every single customer of Facebook, do they have the same email ID, same password, same first name, last name, school, everything?
No.
No. So when you create a Facebook object, don't every single object need to have their own values?
Yes.
Constructor is required in every place. Remember that. Constructor is required every time you create an object. Every single program you have, it should have a constructor. Okay, so to reiterate, when do we call constructors?
When we need new objects.
To create a new object. Every time you're creating a new object, you call constructors. That's rule number one. What is the main purpose of constructors?
To initialize the variables.
To initialize.
Variables.
Be specific.
Instance variables.
Instance variable is what it is initializing, not any other variable. The global variables that do not have static. Okay, the global variables that do not have static written. You are supposed to initialize the instance variable. Remember the difference between all four variables: class variable, instance variable, parameter, and local. The main purpose of constructor is to initialize instance variable. Okay. Now, while writing a constructor, what are the rules?
It must have the same name as the class.
Yes, the name should be always same, just like class.
Yes, it doesn't have the written type.
Doesn't have written type. Very good. Okay, these are the rules. You shouldn't have written type, and the name should be same. Why should the name? Why does the name should be same? Because when you create object, do you create like this? Student S equals new product. Is that how you create?
No.
No. Student S equals new student. Isn't that how you write?
Yes.
So here, since the name, now if you're creating an object of student class, you need to say new student. If you say new product, that's a confusion. You're looking for student class and you're creating object of product. It doesn't fit well. So since the name should be equal, same here and here, this place also you need to have the same names. Okay. Now another point, we will go in detail in the access privilege on that. Never ever declare private unless necessary. If you declare private, you'll have errors. Okay, if you declare private, you'll have errors. We'll go in detail and why this happens. Okay, when we go to the access privilege chapter. For now, just make a rule that you write public. Okay. All right. So here is the question. We have been writing this every single day. Student S equals new student. Okay, we have been creating objects like this from day one, isn't it?
Yes.
Now, do you see any constructor here?
No.
No.
Okay. In the student class, do we have any constructor?
No.
How is it working? This is the student, this is a constructor of student, right? What is the input it takes, this particular constructor?
Integer?
Integer type.
Look
No,
at the line.
no
What
parameter.
does this constructor take?
No parameters.
There is
Oh,
no
they-
parameter.
No
Yeah,
parameter.
there's no parameters.
Nothing. Okay, there is nothing. So technically, shouldn't you have something like this? Public student. Now, isn't this a match? Student constructor with no parameter. We have a student constructor with no parameter. We never wrote this thing, right? We never wrote this thing, but this line still works. Okay, can you call a method that doesn't exist? Customer one dot check balance.
No.
No,
Can you call a method that doesn't exist?
No.
no.
Then how can you call a constructor that doesn't exist? This is the place where we call constructor, right? Every time you create an object, we call constructors. For method, if the method doesn't exist, you cannot call it. For constructor, this one, no parameter, it doesn't exist technically, but you still don't have any errors here. The reason is, when you write a class, if you do not mention any constructor at all, this is what will be silently added without your knowledge. Without you knowing it, the compiler, okay, the JDK setup, it will add these lines of code for you. And that's why you never had a problem when you're calling constructor with no parameter. Okay, you don't have to explicitly write a constructor. If you don't write a constructor in your class, what do you get? This is what you get. Constructor with no parameter. And what does it do in the constructor block?
Creates empty block.
Empty. Okay, it's an empty constructor. It does nothing. Okay, so just to satisfy this rule, JDK steps in. JDK steps in and provides you a default constructor. Okay, this is what we call default constructor. Meaning, even if you don't write a constructor of your own, this will be given to you by default, just as a freebie. Okay, if you don't write any constructor in your program, this will be added on behalf of you without your knowledge. And since they are adding this silently in the background without your knowledge, that's the reason this doesn't cause an error. Even though we didn't write it, it is still working. Constructor with no parameter. It is still working because someone is writing this code for you on behalf of you. That is compiler. Okay, that is the JDK setup. Okay, so default constructor is a constructor with no parameters that does nothing. Okay, what's a default constructor?
Constructor has no parameters
No
That does
parameter,
nothing.
and does nothing.
nothing. Okay, if you do not write any constructor in your class, this will be added on behalf of you without your knowledge. And that's the reason you never had a problem calling this, because someone did add it for you. Just like method, if there is something that doesn't exist, you cannot call it, right? The same rule applies for constructor as well. If there is no such constructor, you cannot call it, but this works because someone is adding it for you. Okay, now you guys follow, right? Default constructor.
Yes.
Okay. So default constructor is only provided if you don't write a constructor of your own. What about this class? Does this class get a default constructor?
No.
No, because
You initialize the constructor. There is a
you wrote a constructor of your own, didn't you?
Mm-hmm.
Since you explicitly defined what a constructor for this class is, this program will not get the freebie. You will get this, okay? You will get this program only if
You didn't mention by yourself.
you didn't mention that yourself. If you didn't mention that yourself, only then you get the freebie, okay? But if you did mention a constructor of your own, you don't get the free version, okay? You don't get this part, okay? Remember, if you do not write one, you will get one. But if you did write one constructor of your own, you won't get the freebie, okay? Why is this error?
Because you're not passing any parameters, you're only passing an integer one, so you have to pass 3 parameters.
We have to pass 3 parameters, okay? Now, let's learn one more concept. Can anyone list all the Java features that we discussed in the first chapter, first session? What are the main features, main concept of OOPS? Inheritance,
Encapsulation, abstraction,
abstraction,
polymorphism,
polymorphism,
Inheritance.
platform independent.
platform independent. Now, can anyone recall what a polymorphism is?
One function, it has different ways to do it, many forms.
So in general, doing the same thing in different ways, right?
Mm-hmm.
Yes.
So here, a bank account could be anonymous. All you have is an account number, you know, fishy bank account, some black money. So all you have is the account number and the money, isn't it?
Yes.
You don't have name. Some people don't have initial balance or initial amount to deposit, so all they need is the account number. I don't need money. I don't have any money. I just want to open an account with 0 balance. In that case, I want to create a bank account object with only my name and account number. Correct?
Mm-hmm.
So there are few people who want to create an account with a name, with some money in the account, and with an account number. Those are some customers. There might be other customers who want to create account as an anonymous person. Okay, they don't want to disclose any names, and they have like billions of dollars, I guess, and they have an account number. Few people want to create bank account with just name, money, account number. Few people want to create a bank account with just the balance, money, and account number, unique account number. And there are other people who don't have enough money, so all they want to do is create a bank account with a name and an account number. There is no balance. So isn't this a polymorphism? Creating bank account in 3 different ways.
Yes. Many forms.
Many forms. So you're doing the same thing, that is creating bank account object, but you're doing that in 3 different ways, multiple ways. That is polymorphism. Okay, let's look at that. All right, so let's see what happened here. There are three constructors, 1, 2, and 3. All of them have different input. One takes string, integer, integer. Another takes string and integer. Another takes integer and integer. Now looking at these objects, what is customer 3 object calling? Which constructor? 1, 2, or 3?
1,
And why?
because it's taking 3 parameters and you're passing 3 parameters.
Input matches.
Mm-hmm.
String, integer, integer. Among these three constructors, we know which one takes string, integer, integer. So this is where the constructor is called for customer 3. How about customer 7?
That's 2.
Constructor number 2. This is the one that takes string as the first parameter, integer as the second. You're passing string as the first parameter, integer as the second. And this one,
Integer, integer. The third one.
the third constructor. 2 integers. There is only one constructor which takes 2 integers. So this is what we call polymorphism. Okay, this is what we call polymorphism. Doing the same thing, that is creating bank account, in 3 different ways. With people who want to create a bank account, name, account number, and some initial balance. Few people with just name and account number. And few people being anonymous, just the amount, the balance, and a secret account number. This is polymorphism. The right term for this is overloaded. Okay, we call this as overloaded polymorphism. Okay, so everyone has a way to do any customization they want. Okay, think about this. This applies to every aspect of your life. When you're creating an account on Amazon or anything, there are different ways you can register. Okay, some as a premium, some as a regular, some as a buyer, some as a seller. In the end, aren't all of them creating account?
Yes.
Yes. Yes.
But in different ways. Now you're trying to buy a car. You want to buy a particular car, Nissan. Aren't there customization available? You want this particular color. Okay, someone wants white, someone wants black, someone wants red. You need a moon roof. You need a rear view camera, a good speaker. Everyone is buying the same model of the Nissan car. But even there, don't they have a customization? Someone wants to buy with a basic setup, basic features. Someone want to add new features. Someone want to upgrade that. So everyone is buying the same car, Nissan. Buying Nissan is the one activity. But don't you do that same activity in 10 different ways? Polymorphism, it applies everywhere. You create an account, you buy cars. Okay, even when you're going to a subway, okay, you want a meat sandwich. Isn't there customization even while you make a meat sandwich? You need lettuce, you don't, you're allergic, you need onion, you need tomatoes. In the end, aren't everyone paying the same amount for a meat sandwich?
Yes.
But don't you customize how you want to prepare that?
Yeah.
So the job is creating a Subway meat sandwich. How you create is customized. That's the constructor's job. It allows you to initialize instance variable. It also allows you to customize how you initialize these variables. You can customize how you initialize, and you can basically set up a brand new object.
So for each type, you need a constructor, or each form.
For every time you create an object, you need a constructor. Yes.
No. Like in this type, you have 3 constructors because you have 3 different types of a function, right?
Right.
So you create 3 different constructors. So each time you need a new form of a function, you need to create a constructor besides the object.
So are you saying we have to create constructors for every time you create an object?
No. So you have 3 constructors on the right? Because you have 3 different types of doing it, right? Because 3 different customers, some of them need 3 options, some of them need 2, or some of them need 2 different options. So each time you're creating a constructor to define which parameters it can take, right? So each 3 constructors have different parameters it's taking.
Yes.
Okay?
So if you are creating a bank account object, you have to choose one of them. Yes.
So you every time, actually the question was every time you need a new form of a function, you create a constructor. Like on the right hand side, you create 3 different constructors.
So if you need a different format of the creation, is that what you're asking?
No, I'm
Yes.
saying,
Sorry, I'm not able to follow what you're saying.
yeah, because I'm confused with like the only simple question is, so there's no way we can do one constructor by doing different types of a function, right? You create 3 different types of constructors on the right? The first one taking 3 parameters, the second one taking 2 different parameters of kind, right?
Mhm. So what's your question?
So each time you have to create a new form of a function, you create a constructor.
New form of a function?
Like, not form, like type. Like in this example, you have 3 customers, right? Some of them need 3 options, some of them need 2 options, and some of them need 2 different options, right?
Mhm.
That's how you
Each time, so each time you create a constructor, instead of doing in one constructor, you have to tell the system that anybody can have anything. So you have to create a constructor for that different options. Still not get it?
Yes, I think I get what you're saying.
Uh, can we use the example in Excel and like I think it's just like creating new rows.
No,
So
it's
tell me here. Okay, Vardha, tell me here. What you're saying, if you want to create a new object, okay, what's your question here? Okay, go ahead. Give me an example that doesn't fit into this scenario. Okay, what is the new thing you want to add to an existing whatever setup we have learned here?
the only simple question is this: instead of creating 3 different constructors, can't we do in one constructor with all these 3 examples?
How?
We cannot, right? We cannot do it, right? We have to write the function.
That's all about customization. Okay, so
Okay.
you're forcing everyone to comply to this way of creation, which is not the whole point of constructor polymorphism. If you have to fit in everything in one constructor, how is that a polymorphism?
It's not. Okay. Yeah, that's what my question was.
Everyone, so everyone has their own needs on how they want to buy a car, how they want to open an account. We have to satisfy everyone's need. That's the whole point of customization. Polymorphism allows you that customization rule. If you fit everything in one, yes.
It's not polymorphism.
Okay, you could allow that, you could do that, but that beats the whole purpose of polymorphism.
Okay, yeah.
You can do that. Everyone, whoever doesn't want a name, okay, let's say you don't have this thing. You can do that, but you're not using the most powerful feature of Java, which is polymorphism. Okay, people can still use this. Okay, how can you do that? Someone doesn't want to disclose a name. What do? They send null, no name.
Oh, you can still do it. Oh, that's what my question. Okay, you can still do it by doing the null value. Okay. You can still use it.
Open an account with just name and account number. They don't have any money. No money meaning what's the value?
0 or 1.
0.
Yeah, 0. And it's still gonna go, oh, okay.
You can still fit in with the same constructor, but why do that when you have such a powerful polymorphism feature?
No, that makes sense because that's what I was asking. Can't you do it in one? You can do it, but you still have to pass a value if you do one constructor.
You have to comply to the signature. That's a default way. But there are
Okay.
ways to work around like this. But why do that when you have such a beautiful, polymorphism?
Okay, thank you.
All right. So someone had a question about some Excel sheet. What was that?
I was asking like it is just like when you create the new rows in the Excel, like you have the same file number, but you add the information in it. So the constructor can be termed as same thing.
If you have same file, meaning?
Like the file name is bank account, but it has different rows in it and the columns, and we can add information in the rows. Like we can add name and then we can add the amount and money, and then comes the next.
Yeah, you could think about it like that. It's like a personal ledger where you keep all the customer records. Okay, and you fill in whatever information that customer wants to disclose. Okay, you can think it like a personal filing system. Yes. Okay, this is what you're saying, right? There is a spreadsheet with name, balance, and account number, something like this.
Yes,
and
sir.
whoever wants to disclose some name, they will get one. Okay, whoever doesn't want to disclose, they'll get a unique account number and this thing. Whoever just wants the name and balance, they get something like this.
Yes.
Okay, but this is much more, right? Java is not about just saving data. Okay, storing information is one part. What do you do with that information?
Use the information.
You manipulate them, right? You increase the balance, withdraw, deposit. Don't you play with that data? Storing is just one part, but manipulating is the main feature. Using that information is the main feature.
Okay, my second question. The constructors. Sorry. Hello.
Rohil?
Yes, sir. Yeah, I have a question. Like the constructors can be created automatically, or do we have to do it ourselves?
All right, so let's see how this behaves in the memory. All right, so in the memory, first of all, when you say customer phi equals new customer, new bank account, what do we do first on this line with the equal symbol?
We are assigning the value to customer 5.
Hello?
We're taking the value from the constructor.
Hello?
This conference will now be recorded.
Okay, so when you create a constructor, when you create an object like this, what happens first?
Reference will be created.
From
Primary location.
mhm.
Okay. What happens next? Yes. Guys, speak up.
Reference assigned to customer.
Is that all? We directly assign the reference.
Blueprint, then location.
Money name and account number inside the bank ACC.
Yes. And what are those variables called?
Instance variable.
Money name, account number. Be specific.
Instance variable.
Variable.
So every time you create an object, what you get in the memory is instance variable. That's all you get. Okay. You get instance variable. Now, what are the values for this instance variable?
ABC 500.
No. What is the default value here?
Nothing.
They don't have value assigned.
So what are the default values?
0 for
Zero.
null, 0.
No, zero.
That's what you get. Okay. So when you say new, okay, let's break it down further now. This new is what this means. You create a bank account object at a location at a reference address. You create instance variable. Always call it instance. You create instance variable with their default values. We don't have anything here. The default values are 0, null, 0. Once you're done with the new part, what comes next? After new, what do you have?
Object.
What is that highlighted line?
Parameters.
What are we calling?
Constructor.
We're calling the constructor. What input did we pass to the constructor?
ABC 505.
So control goes to this constructor with the values ABC 505. Now the ABC for the n variable that we passed, who do we assign that to?
Name.
Name.
That's when this changes to ABC. Now the value 500 is assigned to which variable?
Money.
Money.
It goes to m first, the parameter, and from the parameter m, it goes to money. That's when it changes from 0 to 500. Similarly, 5 goes to which variable?
Account number. Account number.
Does it directly go to account number?
Integer A.
No.
Integer a first.
Mm-hmm.
And inside the constructor, a value gets transferred to account number. Okay, it doesn't directly transfer to account number. Whatever you pass here, it is first passed on to your parameters. And from parameter, you transfer it again. Remember, if I just write like this, will anyone get any values? Is it like automatically getting assigned?
No.
Okay, if I print like this, let's see that. Sys out customer one dot name. I did pass John 101. What will it print? What will it print? I'm passing John 101.
It will print John.
It will print John.
It will print John. So let's see. Is this John?
Oh, it's a null.
That's a null value.
When you pass John, who did get this value? Which variable? Did
The
it
string.
automatically go to
Name,
name?
string name. Yeah.
Mm-hmm.
How?
It's gonna
This
get
is a
the
constructor bank account.
constructor.
It
Tell me,
access to
see guys,
instance.
don't take blindly. Just because I wrote a string here, it will automatically go to the instance variable, is it? When you call constructor, this value goes to which parameter?
No one. N.
The string
N.
n. The
Goes
n
to
string.
which
String
N?
n.
Which one?
No,
First or second?
The first one.
First
it
one.
should go first one.
You
Yeah.
have the value John sitting here. What are you doing with the n variable in this constructor?
Nothing.
So did the name get value John by any chance?
No.
No.
So why are you guys saying name? Why are you guys saying John value will be for the name? Who assigned that value? That's what I was stressing. When I say where does the value go ABC, don't say name. ABC goes to which variable first?
N.
String.
Goes to n. Inside the constructor, are you transferring that value to name?
Yes.
That's when the name becomes John. It doesn't magically happen just because you're sending John from here. Just because you're sending ABC from here. It doesn't magically appear in the name. ABC goes to the first parameter n. Only if you transfer that from n to name, then you'll get the right value here. Until then, what do you get here? What are the default values for name?
Null.
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 Null. What is the default value for money?
0.
0.
Account number?
0.
Zero.
So understand the process, guys. Don't just take it blindly because something sounds familiar. There is double quote here. There is something written string here. It doesn't happen magically. You have to write the code for that. Just like method passing, method calling. When you pass 100, it will be given to the parameter that the method has. It doesn't magically appear anywhere. What will it print?
0.
Null 0 0.
Null 0
Null
0.
0. Yeah.
Now, what will it print?
John.
0
John.
John.
Keep going. John
0 0.
0 0. What will it print?
John
John 100 0.
John
John 0 1.
John 0 100.
John 0 1. Because account number is not assigned. Money M is assigned.
It's John 100 and 0.
Okay, so you're saying John 0 and 1.
100 and
100.
John 0 and 100.
Yes, John 0 and 100.
Mm-hmm.
No.
No, it's John 100 and
John
0.
100 and 0. Yeah.
String and integer M is money.
John 100 and 0.
John 100 and 0.
John
Okay, I'm
0.
getting John
John
0
0
1.
John 0
100.
100.
John 0 100. John 100 0.
John
Any other
0 100.
possibility?
John 100 0.
John 000.
John
So here
000.
I'm printing name. Has name been initialized in the constructor?
Yes.
Yeah.
I'm printing account number. Has account number been initialized in the constructor?
No.
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 Not. So what is the default value of account number?
0.
0.
0.
0.
Is money initialized in the constructor?
Yes.
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 So what's the right answer?
John 000.
John 000.
John 000.
John 000.
Yes. Now that I'm initializing account number, what is the output now?
John 100.
There you go. Did everyone understand that, how it is working?
Yes, sir.
Yes, sir.
That's what this does. Just because you pass ABC find it phi, it won't work unless you're, think about variables like a glass, okay, where you're transferring water from one glass to another. Okay, you take it from in one glass, transfer it to bigger glass, smaller glass. You're just transferring that from one holder, one container into another container. When you pass input like this, it doesn't directly go to any of the variables. It directly goes to the parameters. Be it a method call or a constructor. When you pass anything in the parentheses, okay, when you pass anything in the parentheses, these values do not go anywhere. They directly go to the parameters, to respective parameters, nobody else. N has the value ABC, M has the value 500, A has the value 5. If you want that to be initialized with your instance variable, what do?
You assign the value.
You assign the specific parameter to the instance variable. From the right hand side, when N gets the value ABC, it is on the right hand side. So the value of N is
Assigned to name.
assigned to the name variable. The value of M,
Is assigned to money.
yes. The value phi of variable of parameter A is,
Assigned to account number.
that's why they get these respective values. Okay. Now, new, when you say new, it creates your object at a location with default values. Whatever default values you have here, that's what you get. That's what you get. Constructor's job is to initialize these instance variables. Constructor's job is to initialize this instance variable. That's what we did here. Somebody passes the value to us, ABC 505, and those values from the parameter we quietly transfer to our instance variable. That's when you go get the initialization part here. This is where the initialization happened. These were the default values, right? These are the default values. The first time anyone assigned value to these instance variable was the constructor. Constructor is the place where you put values here. Now the right hand side is done. You created an object and constructor did what? Give the exact technical word.
Initialize instance variable.
Yes. New created object with default values 0, null, 0. Constructor is the one which initialized the instance variable. That's what constructor did. So next time when I ask what this line is, that's what you say. Create an object using new, call the constructor and initialize instance variable, not global, not assignment. Initialize instance variable. That's what right hand side did. Now what happens to customer 5? What happens to the left hand side?
Customer 5, the reference variable.
Reference parameter is what you get. Okay, so here after this line, if I do sysout customer 5 dot money, what will it print?
500.
500. That's why when you did customer one dot name dot account number dot money, when you did that, you got the right values, John, 100, and whatever. Okay. All right. So the same goes here. What happens in this line?
It makes the reference 222, let's say 222, bank account. Then initialize the instance variable.
Do we directly initialize?
No, first put the instance variable in money, name, and account number.
Default value.
Default value. Very good. Then what comes next after you create the object?
Now we initialize it.
Now you initialize instance variable. Where do you initialize instance variable?
By calling constructor.
By calling the constructor. In this case, which constructor are we calling?
Number 6.
Bank account.
M&A.
Third one.
Okay. So what happens when you pass 1,000,008?
First it goes to M.
Money will be million and
Yes.
account
And
number will be
account will go to A.
Right way to put that, very good, is 1,000,000 goes to M parameter, 8 goes to A parameter.
A
Very good.
parameter.
What happens next?
Then reference to will get initialized value 1 million in money, and account will get 8. Name will be null.
Right. What happens when I print customer 6 dot name?
Null.
None.
Null.
Yes. And you can see that here yourself. It's null.
Null, yes.
What happens when I say money?
1 million.
1 billion. 10 million.
And account number?
It will print 8.
Okay. So that's how constructor operates. It is basically used for, as soon as you create objects, you can decide what kind of values you want to assign or specifically initialize to your instance variable. Rather than hard coding values, same value for everyone, now we have a way, 100 different ways to create objects, as many as you want. Okay, as many ways as you want using polymorphism. Okay. All right, so let's see my notes if I missed anything. Okay, so constructors are invoked when a new instance or object is created using operator new. Okay, like we discussed, every time you see a new in a statement, you're about to call constructors. Okay, every time you create an object, constructor is called. constructor name should be the same as class name. Okay, here one more funny thing I can show you. Now, why is this line failing? Don't we have bank account, string int int, string int int?
But we have a return type for that constructor.
Yes. So this is a common mistake. So when you're writing a method, we tend to write void int all the time. So by mistake, if you write a return type for a constructor, this will no longer be a constructor. What will this be?
Method.
It will be a method. Okay, so it will be a method. So technically for this class, how many constructors do we have?
3. Yeah, we have 3 constructors.
3 constructors. So is this a constructor?
We have 2 constructors.
We have just 2 constructors. Same name, no return type. So technically we just have 2 constructors. This is not a constructor. If you have a return type, what is this?
Return type void.
If you have a return type written here, what does this mean? What is this?
Method.
It's not a constructor, it is?
Method.
It's a method. Okay. So since this is not a constructor, this is not recognized as a constructor, this line will fail, saying, as far as I know, bank account has only 2 constructors, string int int int. There is no constructor called string int int. That's what it is comparing. The constructor bank account that takes string int int is undefined, meaning doesn't exist, because that's not a constructor anymore. It's a method. So you have to leave that place empty. You shouldn't write anything, no void, no int, nothing. Only then it will be recognized as a constructor. All right, so that's what constructor should not have the return type, and class name should be same. These are the main 2 things you need to remember. There are no limits to how many constructors you can have. We have 3. You can have as many as you want. If no constructors are defined, compiler provides a default constructor with no parameters, and what will be inside that default constructor?
Nothing, empty.
Nothing.
Nothing. It will be an empty block. Okay. If you do not write any constructor, this still works. This still works even though we don't have constructor. Even if you don't have any constructor, no constructor class, this still works, because compiler adds this for you, default constructor, and it will be only given if you don't have any. If you don't have any, only then you get this. If you mentioned at least 1 constructor of your own, you don't get the default one. You will not get this freebie if you have your own constructor. You will get this if you don't have any. Okay, that's the default constructor. All right, so one last thing. Now, aren't we repeating this same code here? Name account, money account. Can we reuse any of these? Okay, so let's say I have these 2. Okay, I have two constructors. So aren't these lines repeating? Name n account A, name n account A.
Yes.
So we can do something clever. Okay, now here, instead of writing this line in both the codes, this constructor is calling its own another constructor. So there can be a communication between one constructor and another with a keyword this. This is a keyword that points to this object, this program. Okay, you can have communication between one constructor and another, provided you use the this operator. Okay, now let's see what happens here. I'm passing John 101. Okay, I'm passing John 101. Where does John value go?
String n.
String n. Where does the 100 value go?
Int m.
Int m. Where does the value 1 goes?
Int a.
Int a. So we have John 100 and 1. So when I pass n and a to the other constructor, when you say this, you are referring to other constructor. N is a string, as you know. A is
Integer.
integer. So is there any constructor that takes string and integer?
Yes.
Right here. Okay, so the value is now transferred John and 1 to the other constructor. So now this n variable has John and this a variable has 1. What do we do with this John and 1?
We assign it to name and account number.
We use it to initialize instance variable name and account number. When you reach the end of the line, where do you go?
To line number 11.
You go to line number 11. And the last part, money, 100, goes to your money variable. So just like you can call one method and another method, right? I can call withdraw method from deposit. Right? From the deposit method, I'm calling withdraw method. Withdraw takes no parameter. So I'm passing no parameter. You can do this. Similarly, one constructor can call another constructor. But you don't have to say bank account here. Okay, don't say bank account. Say this. When you say this, what you're saying is you're referring to other constructor. Okay, now if I write like this, what is the error?
We don't have a constructor for that.
Yes. M is integer, A is integer. So when you say this, you're trying to reach out another constructor that takes integer and integer. Do we have one? Is there
No.
any other constructor that takes two integers?
No.
That's what this error is for. Okay, the constructor bank account that takes integer and integer is undefined, meaning does not exist. There is no constructor that takes int and int. It is undefined. But when you say n and a, this is okay. N is a string, a is integer. Yes, we have a string and integer constructor. Okay, So rather than writing the same line in two places, okay, the same code, name account NA, name account NA. Rather than doing that, I could just delegate that task, initializing this name and account number from the other constructor. It's doing the same thing, right? You have your dinner at your own place or at your friend's place. In the end, you're going to have dinner. Doesn't matter where you eat. So you do it here or here. Rather than duplicating the same code here and here, you'd rather leave it to the other constructor. Okay, so this is technically used for referring to this object. Okay, you can use it to call constructor. You can use it to call other constructor. But one thing to remember is this should be always the very first line. Okay, you should not write it later. This should be always, the constructor call should be always the very first line in your constructor. All right, so that ends your constructor chapter.